one, uh, having learning that computers don't do homework for you. So he goes like, man, what's all the fuss about computers? So maybe some of you are wondering what's all the fuss about computers and programming specifically. I will not spend time on the organizational notes. I think we've done this more than enough. The only thing that I'm going to highlight is the active participation part. So here it's a reminder that if you want to participate in the discussion, help me out with code, please raise your hand so that I see you, and I will sort of pass the mic to you so that we can have a back and forth and not just me being a talking head. So the schedule right now looks like this. Today's week 5. We're going to discuss pop-up shop and breakout. Then week 6 is going to be Vicky talking about images. Week 7 is going to be back to data. We're going to talk about pandas. Week 8, I'm going to be back with 2D lists. And for week 9 right now, we have actually a data case study, which will put together all the stuff that you will have learned by that time regarding working with data. So that's the plan for the next 5 weeks. You can see the dates on the right hand side, and obviously all these dates are also available on the Code in Place website, in the forum, in the Life After Code in Place forum thread. So as usual, before we go into today's content, we always have quizzes. Vicky is always up for a quiz or 2 or 3 or 5. So here's another one for you, ladies and gentlemen. And today the question is the following. As usual, on the next slide, you will see an image. It will be a photo, an aerial photo of a location. And you will have to write in the chat the name of the location, so what's the place called, as well as the city and the country it's located in. If you get all these 3 things correctly, then you will be declared the winner. And the first person to answer correctly, Vicky said we had people ask for this, so maybe we could actually do this. I said, sure, why not? You will actually get a 1-hour online session, a one-on-one session with me, or a $5 Amazon certificate, whichever you find more valuable, because, if you don't need a 1-hour session with me, $5 on Amazon, is something. So it will be your choice.
Well, why would anybody take a $5 gift certificate over time with you? Because
I don't know, because probably time with me has very different value to very different people. Why, $5 is $5.
I mean, I feel like, if you're going to offer gift certificate, you should at least put your own self-worth at a little more than $5 Amazon
Okay,
certificate, right?
$7, maybe 10. I don't know. I
Well,
think
I
I'm
mean,
pushing
I
the
would
limits
just
here.
say, maybe time with Alex is, oh, we have some other people coming in. Maybe time with Alex is, not worth that much to some people, but I always think time is priceless. And, like I couldn't even get time with Alex. So, I definitely think his time is worth more than at least $5 of Amazon gift certificate. I'll just leave it.
Okay, Vicky, thank you for pumping this up. So now supposedly people are sort of like more pumped up for the quiz. I think
And then
Vicky
nobody
is
gets it
always
right.
doing a very good job of being like my PR manager.
Yeah.
I'm very bad at it. So
Well, if I like decide to retire or quit my job, I'll keep that in mind.
exactly. So the image on the next slide, drum roll please, and here it is. So once again, what's the location name, what's the city, and what's the country where this place is located? Whoever is first decides Alex or $5, $5 or Alex. Okay, we do have an answer.
Wow.
Kremlin, Moscow, Russian Federation.
Wow, that's actually good. I didn't think people would get this because
We
I didn't
had
know where
two
this was.
answers almost simultaneously, but the answer from R.J. Taylor is the more complete one because it includes both the city Moscow and the country which is the Russian Federation. Obviously, Vicky put it there because I'm from Russia. I'm not in Russia right now, but yeah, those routes are long. So, RJ, your choice. You can either, pick my brain for an hour, discuss Python or what have you, or $5 on Amazon, which I think is still good value. All right, so yes, this is the Kremlin in Moscow, Russia. I actually like that you wrote Russian Federation. I mean, that's very much on point. So now let's talk about the
Oh,
plan for
Alex, do you have
today.
any trivia you can share about the Kremlin? Because I don't know anything about the Kremlin. I've actually never been there.
Okay, so the Kremlin is located at the Red Square. The Red Square is actually called the Red Square not because it's red, not because it's made of brick, but because in Russian the word red in the old times, the olden times, it also meant beautiful. So the Red Square was actually the beautiful square, but it's also red in color, so that kind of works out. It has a number of towers. I have no idea how many towers there are, but one of those towers has the clock, which is always shown on national television when it strikes 12 on New Year's Eve, which is like Christmas for Americans. In Russia, it's New Year's Eve, which is a more important holiday than Christmas. Christmas is a very religious holiday in Russia, not secular. And I think that would be enough trivia about the Kremlin
Well,
because,
the one
frankly, I
thing
don't
I
think
will
I know much
say
else.
is most of these places I show I've actually been, so I know something about them. And so the Kremlin is the one place I haven't been to. Um, so not that I want to go to the Kremlin, but there used to be a train called the K3 and K4 train that goes from Beijing all the way to Moscow via like the Trans-Mongolian and the Trans-Siberian Railroad. And so it's very, very scenic. And I think the entire trip takes like 5 days. And then you have to get visa for both Mongolia and then Russia. And so taking that train is on my bucket list of things to do, before I die, because it just sounds very cool. That train had been running until COVID, and then it stopped during COVID. And then recently I read they had a test drive of that train running again. And so I'm hoping that train will actually be back in service soon. So,
I can be in a Russian. I can neither confirm nor deny what you're saying, comrade. So no
well, I
idea.
mean, that's a Chinese train, actually.
Okay, okay.
So, so I don't think you would know anything about that train, because the train is actually operated by China. It's just that its final destination is Moscow.
Okay, got it. So, let's go over the plan for today. The plan is the following. We are going to touch upon the topic of looping over dictionaries. We discussed the topic of looping over lists 2 weeks ago, so this is going to be in a similar vein, but since these two data structures are quite different, so the looping process is a bit different as well. And then we're going to practice it using the pop-up shop problem. We're going to do them in breakout rooms, and then we're going to type up a solution together. I actually think that it will take less time, but I'm just hedging, the risks. And after that, we're going to take a look at the breakout problem, which will take most of our time today. I cannot be certain that we will finish it in its entirety in 2 hours, but we'll give it our best shot. Maybe stay a bit later. So that's the plan for today. And let's go into theory. So looping over dictionaries. Looping over lists is more or less straightforward because a list, given that it has indices, it's a very structured structure, in which you know that index 1 goes after index 0 and it's before index 2, and so you always know what the order of values in a list is. With a dictionary it's different because dictionaries are actually unordered. There is a specific order, I think, starting with Python 3.5 or 3.6, I don't remember exactly. It actually got an order, so the order in which you add items to the dictionary is the order in which it's stored. Previously, it was not so. Previously, it was completely random. Python decided, by itself what the order would be, and it was impossible to predict. But it's a very dangerous proposition to actually try to guess what the order would be in a running program, because it could change at a certain point in time because you're doing some manipulations with dictionaries, and you would get something different from what you're expecting. So that's the interesting thing about looping over dictionaries. If there is no order, how does it work? So let's take a look at an example. I have a very short dictionary which is called jobs. And in this dictionary, I have 4 key value pairs. So remember, a dictionary is a collection of key value pairs. And the key is similar to an index in a list. But in lists, the indexes are always integers. In dictionaries, the key can be any unmutable data type. So for instance, it could be a string, an integer, a floating point, etc. It could actually be we haven't discussed tuples yet, but yeah. So mainly they are usually strings. They could be integers as well. So in our case, we have 4 names: Andrew, Bob, Clyde, and Donald, and each of them as a value has his job, his profession. So Andrew is a banker, Bob is a singer, Clyde is a policeman, Donald is a singer as well. 2 singers in there, and that's perfectly fine. You could have 2 different values. You cannot have 2 of the same keys, but you could have 2 of the same values under different keys. So how do we loop over this? The simplest way would be to write a for loop. It's going to be for loops again. It would be for variable in jobs. And since when you're looping over a dictionary like this, you're actually going to be looping over the keys. This is important. You're looping over keys and not the values. Instead of variable name, I used key here. So for key in jobs, it means that inside this loop, you will go over the keys one by one. So you'd go over Andrew, then Bob, then Clyde, then Donald. And using this key, you can also access the value. So the example that I have here, the printed line is hello. Then I have jobs key. So the key would actually give you access to the value. And then I have the key, which is the name. So if I actually print this out, I would get hello, banker Andrew, hello, singer Bob, hello, policeman Clyde, hello, singer Donald. So in this loop, I can access both the values and the keys using the key variable, which I have inside the for loop. But this is not the only way I can loop over dictionary. I can actually, if I want, loop over values. And in order to do this, I would need to, before we go into values, I could actually be very explicit over what I am iterating. And instead of writing jobs, like previously just for key in jobs, but if I want to be unnecessarily explicit, but I could choose to be so, I could write for key in jobs dot keys and parentheses. So this is a method which returns a list of keys that you iterate over. So this will give you the same result, same exact result. There is no difference between the first option and the second option, gives you the same result. So usually you just use for key in jobs. So now you could iterate over values. And to iterate over values, this is actually logical from the previous one. In the previous one, we have jobs.keys. Now we have jobs.values. So values is also a method which gives you a list of all the values which are stored in the dictionary. So this gives us access to the values one by one. Like I said, the order is determined by whatever order was given initially, or the order that the key value pairs were added later. In our case, it would go first banker, then singer, then policeman, then singer. But it's important to understand that if you iterate over values, you have no direct way to access the keys which are connected to these values, because you lose the key value connection. You only have values. So here, if I run this code, I would get, we have a banker, we have a singer, we have a policeman, we have a singer, because there are two singers. But you would not be able to directly know, like, what's this banker's name? I mean, you could then check, go through all the names and check if that name's value is a banker. But then if you have, similar duplicate values, then you would never know, like the first one, is it Bob or is it Donald? The fourth one, is it Bob or is it Donald? So when you're working with values, you do not have direct access to keys. And one more thing that you could do, there is another method which is called items. And items gives you both the key and the value at the same time. So it returns two items. The first one would be stored in the first variable. The second one would be stored in the second variable. They're divided by a comma. So this is important. You have to list two variables here, because otherwise you would get an error. So you would go for key comma value in jobs.items. And during the first iteration, you would have Andrew as key and banker as value. Second iteration, you would get Bob as key and singer as value, etc., etc. So if we run the code that I have here, you would have Andrew is a banker, Bob is a singer, Clyde is a policeman, Donald is a singer. And here you have direct access to both the key and the value. You do not need to use the square bracket syntax to access the value, because you get it immediately inside the iteration and it's stored in one of the two iteration values. Let me take a quick look if this is going to be broken into rooms. Okay, it's okay.
There's no question, Alex. Just
Yeah, I got it.
keep going. If we have questions, we'll flag you.
Sure, thank you. So we've discussed iterating over keys, iterating over values, iterating over both keys and values at the same time. So that's three methods, like keys, values, and items. One more thing that we can do, if you remember when we discussed looping over lists, we talked about the enumerate function. So the enumerate function allows you to also get a number for each iteration of the cycle, and you can usually use that number. You can actually use that number inside to have, for instance, a numbered list. You can do the same with dictionaries, although the syntax will look a bit more difficult. But here it is. You would go for number, comma, and then this is important. You would have to include key value separated by comma inside parentheses. And if after this you write in enumerate jobs.items, you would actually get both the key value pairs from jobs items and the number from the enumerate function. And you can also, much like with the list, decide from which number you want to start, because by default you start from 0 because it's like index based. But if you want to start from a different number, you can do that using the optional parameter, which is called start. So in this case, we would get something like 1, Andrew is a banker, 2, Bob is a singer, 3, Clyde is a policeman, 4, Donald is a singer. And if you look at the print statement here, I'm using an F string, and it's very clear what the message is going to be. because I'm using very clearly named variables like number, key, and value. I could have actually used name instead of key. I could have used job instead of value, and then it would have been super clear. It would have been number dot name is a job. And that's very easy to read. You instantly understand what's going to be printed to the screen. In this case, I just used key value because I'm talking about key value pairs, but you can name these variables whatever you want. So these are the 4 types of iterations you can do over dictionaries. Once again, the first one is over keys. The second one is over values. The third one is over both keys and values using the items method. And the fourth and final one is over numbers, keys, and values using the enumerate function. And inside this enumerate function, you use jobs.items to get the list. And the enumerate actually provides you with a number to go along with that. So this is it in terms of theory. And before we go into practice, I'd be more than happy to answer any questions on what I've just talked about. If you have a question, please raise your hand. I'll answer to the best of my ability. I'll try looking at the chat in parallel. Maybe there is something interesting in here. No, I think just discussion. You know, whenever there are no questions, I usually say either everything is clear or everything is completely ununderstandable. Hope it's the first, but I do not see any raised hands, so that would probably mean that there are no questions. I see like about 25 people. I would encourage more active participation because, you know, when we previously had like 50 or 60, it was easier to, you know, to get 4 or 5 people involved. Like right now it's going to be a bit harder because there are less people. So once again, I would encourage you to participate in the discussion. Anyway, pop-up shop, what's the problem about? So in this problem, you are given a dictionary, which is called fruits. And this dictionary represents fruit prices at some local pop-up shop. So the keys in this dictionary are the fruit names. So each key is a different fruit name. And the values under those keys are the fruit prices. So basically you have a dictionary with prices for each of the fruit types which is present at the pop-up shop. The task is to write a program that will ask the user how many of each fruit types from the pop-up shop, from the dictionary, the user wants to purchase. And it should go through all of the fruit types, ask this question for every fruit type, and the end result should be a total price for all of the fruit that the user wants to purchase. So that the user understands, how much money he needs to pay, whatever. So let's look at an example. Let's say that this is the dictionary of fruits, and it doesn't really matter what the dictionary will be because I think it's different. It's quite different in the task, but it doesn't matter whether it's this or that. It's just that the algorithm should work. So for instance, I have apples which cost 1.5. I don't know what the currency is. I have bananas at 4. I have kiwis at 3.5, mangoes at 5. And if I run the program here, here's what it would look like. At least one of the options, what it would look like. First, I would ask, like the program would ask, how many apples do you want? So this is the first key in the dictionary. For instance, I say 3. And then I go, how many bananas do you want? And for instance, I don't want any bananas, so I type 0. And then you go, how many kiwis do you want? I say 2. How many mangoes do you want? I say 1. And since this is the end of the dictionary, I ask the user about all 4 fruits which are present there. I get the result, and it says the total price is 15.50. Okay, we have a currency. This is dollars. I have no idea whether this is representative of real prices. Probably not. So this is an example of what the result of the code running would look like. And as usual, Uncle Chris now wants you to code pop-up shop. But before we go into breakout rooms, once again, if you have any questions, comments on this assignment, please let me know so we can clear up any questions that you might have. It has durians and other odd fruit. Yes, it does. But you can come up with your own, fruit dictionary. If you do not like, those smelly Asian fruits, you are not, obliged to use them. You can use whatever local stuff that you want.
Question, Alex. How long do you want the breakout rooms to be? 10 minutes, 15 minutes? I'll set it.
I would go 15 minutes max. I think it shouldn't be more than 15 minutes. And if we see that, people are doing this faster, we can maybe actually close a bit earlier.
Oh, someone has a question. I think Manzi raised her
Okay,
hand.
Manzi, yeah, shoot.
Where are we supposed to write the program?
Okay, good question.
You can actually write it in the SIP IDE. Just open up your own project. It would work in the SIP IDE. Do you know how to do that?
Let me
Yes.
quickly show so that everyone knows, so that everyone is aware, because it's a good question. So if you look at my screen right now, first of all, there is like a starter code download. If you go into the main forum and go live after code in place version 2 and go to the table with all of the topics, for week 5 there is starter code download. If you press here, you will get to this document, which gives you the instructions, which are a bit different from what I talked through in terms of the specific text. But you're free to write whatever you want. There is no obligation to be word for word, because there is no auto test for this one. And you can either do it in an ID that you already have, like VS Code, PyCharm, whatever. Or if you don't have an ID, then you can go to code, and here you have your own, and in your own, if you press new console project, you will get your own empty IDE where you can write whatever you want and then run this project and see the results. So I hope that answers the question as fully as possible. Any other questions, or shall we dive into the rooms? Okay. So are we all back? I think 28 participants. I think that's everyone. For some reason, I cannot see my mouse. Okay, so we're back, and I know some groups managed to solve this problem. So some were still in the process. But at least you got, you tried to wrap your, mind around this assignment, and now you obviously have some, questions about how to do something, and you have an understanding about how to do other things. And right now we will solve this one together. So let me share my screen as well. Just give me a second. I will. Just for ease sake. Well, actually, no. Actually, let me open VS Code. Let me do this in VS Code to show you. I mean, if you haven't had experience with more or less professional IDE, that would be helpful. So just give me a second to share my screen. Okay, there we go. VS Code. And let me open a new file. It's going to be a Python file. There we go. So let's see what we need to do. Let me quickly do a dictionary. I'll call it fruit prices. I don't remember. We had apples at 1.5. We had bananas, or I had bananas at I think 4. I had kiwis at 3, and I had mango. Those, yeah, these are actually supposed to be singular. Apple, banana, kiwi, mango. And actually, let me make this maybe. How do I make this larger? I have no clue how to make these larger in VS Code.
What about Control Plus, Alex? To enlarge
Plus.
your screen.
Let me try that. Okay, there we go. Thank you. So I hope this this looks better, and we have some prices, and now, so the first thing that we need to do, we need to ask our user to, why am I speaking? Tell me, what's the first thing that we need to do, guys and gals? What's the first thing we need to do here? Anyone, raise your hand. Talk to me. I'm your radio host.
And
Let's talk about it.
initialize the total price variable.
Okay,
Or total
that's one of the ways we could do it. I would say that's the easiest way to do it. So to explain why do we need to initialize a variable here?
Because if we just start adding to it, we're going to want to add it as we go. I don't think it'll like being added to if it doesn't exist yet.
That's true, but my question probably is more about why do we need this variable in general? What's this variable for?
It's going to be where we tally up all the cost of the apples and the fruit as we buy them.
Exactly. So it's a variable which we're going to use to track the current total as we go from one fruit to another. Yeah, so it's going to get higher and higher and higher and higher, much like, numbers on a calculator. So we could call it whatever we want, but I would go like with total cost or total price, total money, whatever. So what would the initial value be? Total price equals
0.
0, obviously, because we haven't bought anything yet. We haven't expressed our desire to buy anything yet, so why would we pay any money? All right, so thank you, Martha. Anyone, what's the next thing that we need to do?
You need a loop.
We do need a loop. What kind of loop do we need?
You can use one of several loops. You can use, probably the easiest would be the key loop. You could use.
No, I'm saying like there are only 2 loops in Python. There is the for loop and the while loop. Which one are we
Oh, yeah. So this, I would do a for loop.
Okay. For loops are usually done when you know how many iterations we're gonna get. Do we actually know how many iterations we're gonna get?
No.
I mean, you kind of do because you know like how many items are in this like dictionary.
Yeah, so I sort of, as a user, you do not know in advance because you don't see the dictionary, but as a programmer, you understand that you have a dictionary which is finite, which has a very specific number of key value pairs. So in that sense, we do know in advance how many iterations there are going to be, and we can use the for loop here. Okay. So what should we iterate over? Because there are, like Vicky, like you said, there are different ways of iterating over this dictionary. Which one do you think is the best?
Someone said in the chat we loop over len fruit. I'm not sure I want to do len fruit, but
So then the question is, if we iterate overland fruit, let's look at it. So for instance, we could go for, let's say you can't iterate directly over len fruit, but you can iterate over range len fruit. So in this case, len fruit would be 4, and a range would give you, it's not fruit prices, obviously. Yeah. So this would give you a sequence which goes 1, 2, and 3. Then the question becomes, what do you do with these numbers? So you get I equals to 0, then I equals 1, I equals 2, I equals 3. How does that help you iterate over the dictionary?
Alyssa has her hand raised.
Okay, yeah, thank you. Alyssa? No more hand raised. Did you have a question or a comment? Because just jump in with whatever you had. All right. So I didn't see in the chat who wrote about range, so I'm not sure who I'm talking to.
Okay,
Min.
and then Min and Carlos said that we can loop over key and value. That's one possibility.
Okay, so looping over the length, though I see that actually Min proposed this. So to understand looping over the length, the range, will not help you in the sense that these numbers do not have any direct correlation with the key value pairs because dictionaries do not have indices. But the idea to use keys and values is a good one, because remember, we can use the items method. So we could go for key value in, then we have the name of the dictionary and items. This will give us both the key, which is the name of the fruit, and the value, which is the price of the fruit at the same time, which is sort of nice. It makes life easier. And I would actually name these variables to mean what they are. I would say here for fruit and for price. So for fruit, comma, price, and fruit will hold the name of the fruit, price will hold the price of that specific fruit. So if we do this inside, we're gonna iterate over key value pairs inside this loop. And the next question is, what's the next action? The next action we need to do? Can someone help me out here?
User input.
User input, exactly. So what does user input look like in this specific case?
I don't think I should be talking, but
But you are, so.
I will only talk like no one else talks. So
Okay, so I'm reading
okay,
the
okay.
chat at the same
Somebody
time. So the
said
idea
number
is
of fruit. Input.
number of
Number of
fruit,
fruit.
yes.
That's good.
Or you could say quantity of fruit or whatever. Let's say, yeah, number. I'll just stick to number. That's going to be the variable which will hold the number of each specific fruit that the user wants to buy. And then we need, as Min correctly wrote, we need to use the input function, which actually gets input from the user. And inside the input function, you could type whatever you want, but since we want the user to understand what specific fruit he's being asked about, how do we deal with this? How do we write the prompt inside the parentheses of the input function? What do we write here? Clive, shoot.
Hi, we can use an F string.
We can use an F string, absolutely true. Okay.
How many curly brackets?
Yep.
Fruit.
Uh-huh.
Do you want?
Something like this, right?
Yep.
If we want plural, because I prefer to, how many, you don't say how many apple do you want. I mean, you could say that, but that does not sound very linguistically correct. So if I want to add plurality, how do I do that?
Bracket S after the fruit.
Yeah, so if I place the S here, then I would be asked how many apples do you want, how many bananas do you want, etc., etc. Good. So we have the input, but there is one issue that we need to pay attention to when reading input. Can someone help me out? What's the issue here?
Converting it to an integer.
Yes, how do we turn this into an integer? Because if we get a string, we're gonna get all sorts of weird errors.
I guess you could do number equals int number,
We could do
or you
that.
can just put an int in front of the input.
Yeah, I think that's the way it's usually done. You're absolutely correct. We could have done number equals int number, and that gives you the same result, but then you sort of go, why, waste space? You could just do this, same result. So now we have, the way this works, we have the inner parentheses, we have the outer parentheses. So whatever's inside the inner parentheses, it's like in math. The inner parentheses they work first. So first, we get the input from the keyboard, and this input is stored as a string, because any input which is received from the keyboard is stored as a string. And then, using the int function, you turn that string, you at least attempt to turn that string into an integer. For instance, if you type something which is not an integer, you will get an error, but in our case, we're not doing, error handling. We trust the user to input an integer. And then this integer is turned into, this string is turned into an integer and saved into number, which is the variable. So what's the next thing we need to do? Now we have, the number of a specific fruit that the user wants to buy. What's the next thing we need to do?
Multiply the number by the price.
Okay, so I would go number multiplied by price, and what do I do with this?
Add the total to the total price.
Okay, so two ways I could do this. I could say total price equals total price plus number multiplied by price, but that's a bit of a mouthful because you have to type total price twice. Why do that when you can use the shorthand, which gives you the same exact result? So you could type total price plus equals number multiplied by price. So, and this means that the number which is input by the user will be multiplied by the price, which is the value under that specific key. So when we're asking how many apples do you want, this is going to be the price. When we're asking how many bananas do you want, this is going to be the price. With kiwis, this, with mangoes, this. And the total for each specific fruit will be added iteratively to our variable, which is going to increase and increase and increase, and after the iteration is done, it's going to hold the total price. So the last thing we need to do after this loop is done, we need to inform, our user of the results. So how do we do this? What's the last thing we need to do?
Print the total cost.
Yes. So how do we do this? We obviously use print. So what would we type here?
F string again.
Yeah.
Yeah, so the total cost is
The total cost is
$sign
$, yeah.
and the curly brackets total price.
Total price. And let's say period at the end. Total price. So let's run this and see the result that we actually get. Why are you? Oh, Julius, what are you doing? VS Code, what are you doing? No, okay, how about we run it in a dedicated terminal? Oh, it probably wants us to save it. Okay, let me just save it to to the desktop, whatever it's called. All right, so it asks us, how many apples do you want? I say I want, I don't know, 3 apples. How many bananas do you want? I want, I don't know, 1 banana. I do not want any kiwis. I want 2 mangoes. And it says the total cost is, and here's an interesting thing. It says $18.5. But in real life, you would not say 18.5. You would actually say 18.50. So here's an interesting question. I know that this is maybe a bit, beyond the scope, but my question is, does anyone know how we can format this so we actually get the correct representation of a price, so 2 decimal points after the period? Has anyone had this experience?
No, but I bet Dr. Google could tell us.
Sure it can. That I'm sure of it. So yeah, I see the answer from Leah, and Leah's answer, as far as I can see, hold on, almost correct, very close to being correct. So the way you can do this inside f-strings is actually after the value that you want to print, you can include a colon, and this colon signals Python that you are going to tell it, what the formatting is going to be. So after the colon, you can specify the format, and if you want decimals, the way to do it is you put a decimal point, then you type the number of decimals that you want, in our case 2, and then you put F. F is for floating point. And if you do it like this, then Python will know with this syntax that you want the number to be represented this way. So Leah, the only difference is, the order of the period and the colon. It should be the other way around.
Inverted. Sorry.
Yeah. Otherwise, you're absolutely correct. So that's the easiest way to do it. So if we launch this once again, I want 1 apple, I want 1 banana, 1 kiwi, 1 mango. And now it's, instead of saying 13.5, it says 13.50, because that's the way it works when you ask for 2 decimal points. Okay, so I think we are done with this one, and we're ready to go into Breakout. But before we do, once again, I always ask, do you have any questions on this specific implementation, or maybe you have questions on how you try to do this differently, because obviously this is not the only way to do it. Any questions, comments? This is the time. All right, probably not. So we will obviously share this code with you so that you have it to look at. And just give me a second. We'll go back to the presentation and talk about Breakout, which is obviously a more involved assignment, not as easy as the one we just had right now, which is a bit of a warm-up. So Breakout. Breakout is a generic name for a game which has been, around for a long time. I remember playing it back in the 90s. It was called Arkanoid. Cool game, spent countless hours playing it. So you have, a number of bricks, you have a paddle, you have a ball, you have to deflect the ball with the paddle into the bricks to destroy them. And you have 3 attempts, to do it. You have to remove all the bricks to go into the next level. And I see, Alyssa, you're saying it was invented by Steve Wozniak. I can't confirm that or deny that. I don't know, but it could well be the case. So what we're going to do, we have a number of milestones that we need to do. So we first will need to create the bricks on our canvas. So we actually need to draw the bricks, and we need to create the objects which will represent those bricks. Second, we will have to add a bouncing ball, because without bouncing ball, it's just going to be a boring static picture. We will add the paddle. So the paddle is the thing that's responsible for, sending the ball back into the game. the important part. We will have to check for collisions of the ball with both the bricks. So then it would have to bounce and actually destroy the brick and the pedal. It would also have to bounce off the pedal and also the walls. So the left wall, the right wall, and importantly, the top wall, but not the bottom wall, because if the ball misses the pedal, that's one of the end. Lose a life, so to say, and you have 3 lives, and if you lose all 3 lives, the game ends. So we will need to implement that as well. If we get all of this done, but there is a quite popular nasty bug when you're programming Breakout that almost everyone encounters. It's called the sticky pedal bug. When you actually have the ball get stuck inside the pedal and behave very erratically. So this is something, if we do have the time, we'll deal with it as well. And I think that's everything for the presentation. So give me a second, I'll go to the Code in Place IDE, because we're going to be using that, and we'll start on it. I already have it set up. Okay, so here is the code and the assignment. We have a number of constants already provided for us. We have the canvas width, the height, the location of the pedal on the y-axis, the width, the height of the pedal. So this is not something we need to come up with. We have the ball radius, the gap between the bricks, we have the width of each brick actually calculated for us, we have the height. So these are things that we do not need to worry ourselves. We can use them. And the only actual code that we have is the creation of the canvas. We don't have anything else. I see a question, how do I get out into the Breakout on Code in Place? So in order to get into Breakout and Code in Place, let me show you. So you go to Code in Place, and for me it's under student. If you look at your student path, you would need to go down into week 7, I think. And in extra content, you will have this optional breakout. So if you click here, you will get into it. So there you go. Let me make the text larger once again. There we go. Okay, so let's take a look at the milestones that we have. So the first one is create bricks, and what we have to do is set up in the top part of our canvas. As you can see, the number of bricks is like 10 across, and actually 10 vertically as well. So it's 10 by 10. We have a total of 100 bricks. And these bricks are of different colors. So we have 5 different colors. We have 2 lines of red bricks, 2 lines of orange ones, 2 lines of yellow, I think. Then we have green, and then we have cyan, the color that I love to hate, but it's here. So what can I do? And the only value it says here, so we have, a lot of values specified as constants, and the only value we need to calculate or compute is the x coordinate of the first column, which should be chosen so that the bricks are centered in the window, So in our case, I actually think that if we have, let me see, given this constant, they will fill up the entire width. So they're going to go from wall to wall. There's not going to be a space on the left or on the right. So this is the first thing we need to do, and I'm actually going to split this into helper functions. So the first helper function is going to be called draw bricks, and I'm going to pass the canvas as the parameter, because we will have to draw on that canvas. We would not be able to do it without it. So let's define these functions, and here is the place where I would love to hear your ideas on how we could do this. How do we draw these bricks? Anyone? Any ideas? Just raise your hand or just talk into your microphone, whatever.
The easiest way is just to write 10 lines, just to hard code 10 lines, but that's not necessarily the most elegant way.
That's true.
That's how
Drawing
I did
10
it last
lines
year.
is not the most elegant. That's a good way to
However,
put it.
to show that I have grown and matured, that's not how I did it this year.
Okay, so do you want to share with us how you did it this year?
Sure.
Let's
I
go.
used a for loop.
That's
Um,
good.
I actually created, well, okay, there's probably a slightly better way to do this. I actually created a list of colors, okay, in the
Okay.
orders that I wanted them to appear. And then I created a for loop. Okay, it's like for I in range 10. And then I basically use the enumerate function that you talked about last week to basically enumerate over the um, I guess like indices and the value of that list. And so basically, the value is like the color, okay? And so like it would give you the right color for basically each row. And then within those two nested for loops,
But
okay, I would
can you take me through the, because you just now talked about nested loop, can you take me through the second loop? So you have for I
okay,
in range 10.
okay, I have a list. You got that, right?
Yeah.
Okay. And then the first loop is for I in range 10.
Yeah, and the second
Okay.
one?
And then I have a second loop nested within that for loop. That's for a comma color in enumerate the name of my list, which happens to be colors.
Okay. So basically you have a list which has the colors in them. It sort of goes like red, red, orange,
Yeah,
orange, yellow, yellow, green,
yeah.
green, cyan, cyan. Okay, and so basically here you get the indices in A, the variable A, and the color is actually the color which is stored under that index. And that's how Python knows which specific one you're using. This is actually one of the ways that you could do it. I think it works. I did it a bit differently, but we can use this one. I don't mind. So let's go for so it's like red, red, orange, orange, then it's yellow, yellow, green, green, and cyan, cyan. Okay, we have the list. I can maybe make it a bit more so that it
I will
actually
say,
fits.
Alex, okay, and so when I look up that enumerate function, okay, ChatGPT actually told me that you could use a syntax such as like multiply by two within
That's true.
your enumerate function. But
That's true.
did not work for me, okay? Because what I wanted to do is to have the colors consecutive, like two reds, two orange, two yellow. If I were to do like multiply by two, okay, ChatGPT thinks it's going to give you consecutive, but it actually lists the five colors first, and then it repeats those five colors again. And
But let's
so
let's
it doesn't look the way that I need it to look.
But I'm wondering, okay, hold on, if we do this, no, yeah, it wouldn't work because I thought maybe you could do it here, but then that would give you a different, that would give you, so that's not going to be helpful. So I would stick to this. This is easier to
Yes.
read. So let's stick with that. Okay, so now you have I. So I is the number, sort of the, let's call it the index of the row that you're working on, correct? Okay, if you don't mind, I will switch it to row so that everyone understands what I represents. So we have rows from 0 to 9.
Well, I mean, I actually defined a row. I actually set row is equal to A, which is the indices. It's the same thing.
So my question is, were you drawing row by row or were you drawing column by column?
Let me see. It drew so quickly, I don't actually know.
But I mean, the logic of the program, you should be looking at the logic and
I know,
understanding.
I know, I know. But it was late. Okay. I believe I was probably actually drawing column by column like this.
Okay, because uh, I would probably do it row by row simply because I'm thinking that each row is of a specific color, and I'm going like it just fits into my mind,
Yeah,
that
yeah, yeah,
you understand the
yeah.
logic. So,
That's
but
fine.
it doesn't really matter because you can do it both ways. So in our case, then this I guess would be the column for column in range 10, and here you have row and color from enumerate colors. Colors like this, yeah. So, and then what do you do inside this nested?
Well, if somebody else wants to talk, I'm happily to relinquish. I'm
I
just
don't
going
know. I
to.
don't see any raised hands. Does anyone else want to talk, or is it just going to be me talking with Vicky, which is fine by me? But I mean, I hope you guys came here not just to listen to us, have a nice dialogue. Anyone, any ideas? Even if they're wrong, I don't care. Just shoot something at me and we'll discuss it.
Well, draw the first brick.
Yep.
Yeah, Martha, shoot.
Um, so what is it? It's canvas dot create rectangle, and we'll
Yeah.
what's the top X is let's see, the X is that direction.
X is horizontal, yeah.
Yeah. So I think mine ended up being basically at 0, but I created, I think, another loop to give me different X's as I went across the row.
But I mean, we actually have a loop which goes a column. So remember, we have the numbers of the columns going in this
Oh,
specific
right.
implementation
Okay,
from
so
0
we
to 9.
go column times the brick width
Yeah.
plus gap. So like those in parentheses. Wait, do I need
Is
that
this
much?
one? No, I didn't get it. And I think we need to add them together like this.
Yeah.
Okay, so that would be the X. And you know what I would do? It actually sort of that this is very clear. I would go like X is this. And then what would the Y be?
I think I used the starting Y as like 5 times the brick height, and then iterating it without caffeine.
Let's try, yeah, let's go brick height by 5. I mean, why not? Let's see where it takes us. And then, so the question is, if we have column responsible for the number of the column, what is responsible for the number of the row?
So must be row.
It is. Obviously it is here, yeah, so good. So, and then we have row multiplied by...
The brick height plus, I used the brick gap again.
Sure. That's the way you do it, because you need to include the gap, so the next one is drawn not near, but after a gap. So now we have the X, we have the Y. So that's, as you correctly said, that's the top left one.
And
so
then
now we need to have the bottom right one.
X plus brick width, Y plus brick height,
Lovely.
and then the color.
And then the color, which we already have stored in the color, whatchamacallit, variable. Yeah. Okay, so this will actually, let's run this. Let's see actually whether we actually get anything here. And we do. So nice. We have the 10.
So long.
Sorry?
It took me so long doing it by myself that I didn't have.
Come on, but you got there.
Great.
That's the important part. And we do have 10 by 10 in the colors given. So I think we're good here. Then the question is, there is one thing that we need to do about these bricks, because at the moment we are drawing them, but that's about it.
Returning the variable that, like the shape name. Do we need to return that?
Yes, but where are we going to store these bricks?
I guess in a list.
Sounds good to me. So how do we work with that? How do we do this list?
Initialize a list under draw. Well, we're gonna have to return it. So on line 27 under draw bricks, I don't know what you want to call it, like brick list.
Okay.
So that we return the list.
You could actually call it bricks, and I think that's as good a name as any.
Do we need to initialize bricks there in the main, or is it okay to just return a list?
I think it's cleaner to return a list from the function.
Okay.
So we would actually return the list here, but we do need to initialize it first. How do we do that?
I don't remember what the append, we haven't initialized it in the function, and I don't remember the append command, so.
But the append is not the initialization, because first you need a list which doesn't have anything.
Just bricks or brick equals, and then the brackets.
Yeah, so this is an empty list because initially, obviously, it's empty. But then, as we go through the bricks and we draw them, we'd actually need to add them to this list. So first we need to save each specific brick into a variable. So where do we do this?
On the canvas, create rectangle line, but
yeah,
I don't remember the command for adding things to the list. So
okay, so but basically to make it easier to read, because if we stick append in here, it's going to be impossible to read this line. So I'm going just simply to save this into a variable called brick. And then what you're looking for, can someone help us out here? How do we add this brick to our list of bricks?
Oh, is it bricks equals or bricks dot
append,
and then in the bracket you put in brick?
Yes.
Okay.
Absolutely correct. That is the correct answer.
And we need to return bricks, not brick.
Sorry?
On line 38, we need to return bricks, the list.
Yes, thank you. That's of course I made the mistake on purpose. And you noticed it, so good job. Good job, Martha. And now we have like the full story. We actually have all of the bricks stored in a list. Then this list is returned to us from the function to the main function and saved in this variable. So now we not only have these bricks on the screen, but we also have access to a list of these bricks as objects, which is necessary because we're going to interact with those objects and we will have to destroy these objects once they're hit by the ball. So this is important. And I think for now, I mean, if we launch this again, obviously we're going to get the same canvas, but now we have stuff in memory. And we are done with the first milestone, so we have the bricks created. Good stuff. So now we need to add a bouncing ball. And for that, I am obviously going to do a new function, which is going to be draw ball. Though actually, probably a better way would be to like create. I call this now, thinking about it, create bricks, and I would have create ball on the canvas as well. And you can guess, since we need the ball as an object as well, I would go ball equals create ball canvas. So now we need to do the ball. So I'll change the name here. So it's going to be create bricks, and this one is going to be create ball on the canvas. So can anyone else help me out here? How do we create a ball? What do we need to write in this function?
I mean, you need the same kind of idea. You need
It's similar.
uh, use create oval to create the ball, and then you need the
So it's
create
going to be
rectangle.
canvas, create oval to create a ball. What are the parameters that we need to create a?
You need the top left-hand coordinate and the bottom right-hand coordinate.
So it's
And then
basically the square which is around the ball. So we can also work on the X and the Y, whatever it is, and then what's going to be the bottom right one.
so the bottom right, well, okay, it
Do we
would
have the size of the ball?
right, it would be X, Y, okay, probably like plus twice the radius. I think you're given the
Yeah.
radius.
Yeah. We're given the radius. You're absolutely correct. So it's going to be ball radius multiplied by 2 because we need the diameter. Sorry. Okay, that's just air traffic. So like this, and then I think we need the color, correct?
Yeah.
And it's just going to be black.
I think it's blue.
The ball?
Yes,
Oh,
the
no.
paddle is black.
The ball is black as well. They're all black.
They're all black? Okay. All right, okay.
It
Whatever.
doesn't matter, but
I don't think
mean,
it matters, so
it
just
does not.
humor me and then you can make it blue. Because
Okay, I can do that just to humor you. So we have it created. Obviously, we'll need to return it back to the calling function. So we have return ball. So the only question is, what are the X and the Y? How do we define the X and the Y of the ball? Obviously, we probably want it to start in the center of the screen horizontally and somewhere between the bricks and the paddle vertically.
right. If you want the center of the canvas, right? The way that I defined it was canvas width divided by 2, subtract the ball radius, and then canvas height divided by 2, subtract the ball radius.
Yeah, so this will give us the middle horizontally. And if we want it to be in the exact center of our canvas, we can do the same with the vertical. I need to, just give me a second, I need to let my cats out there scratching the door out, destroying my door. Okay, I'm back. So we calculate the X, the Y, we create the object, we return the object, it's saved here. Let's run this and see what it gives us on the canvas. So now we have a blue ball in the middle of the canvas, which works fine for me. I mean, this is as good place as any where the ball could be located. But this is not the only thing about the ball that matters, because while the bricks are stationary, the ball is going to move. The x and the y coordinate of the ball are actually saved in the object itself, so you can directly access the current coordinate of the ball using this object's method. I don't remember them by heart, but something like get x, get y, or something similar. The question is, what else do we need to know about the ball at any given time?
Its velocity.
Velocity, exactly. So velocity, as we know, is a combination of speed and direction. And speed is it given to us? I don't even remember.
I think it is given. I think it's 10.
Oh, okay. It says here like have variables. I don't know why they are variables, because they're probably have to be constants, because the speed is not going to change. So I would actually define them as constants. I would go ball speed equals 10, and I will use this constant in the game. So that's one of the things we need to know. We know this. We need to know the speed, and the second thing that we need to know the part of the velocity is direction. So this is something we already worked on. Remember when we did Baby Snake? In Baby Snake, we also had to store the direction in which the snake is moving. Does anyone remember what we did? How we saved this information?
I'm not sure what you're asking, but you know.
I'm asking anyone who was there when we wrote Baby Snake and remembers anything.
I mean, if you like hit a wall, the direction reverses. Is that what you're saying?
Exactly. But we have to store it somewhere. So in which direction is the ball moving? Because it could go up left, up right, down left, down right. How do you save this state?
So confused. Sure what you're asking, but
So once again, let me talk through this once again. So inside the game, the ball will move at a constant speed of 10, but it could move in any of 4 directions. It will always move diagonally, either up, left, up, right, down, left, down, right. And at any specific point in time, we need to know which direction the ball is going right now. So how do we do this? How do we save this information about the ball?
well, I think you need two variables that accounts for the x and y
Yeah,
velocity, right? And then you would assign like plus minus to account for the direction.
so let's
Is that
call
what you're
this,
asking?
that's exactly what I'm talking about. So we could call this, let's call this velocity. We don't actually need 2 variables. We could do this in 1 variable and stick it in a list, and I think that's the way it was done in Baby Snake. So the first velocity is horizontal.
I think it's
So,
easier if you just save it in like 2 different variables, because for like regular people like us, okay, we don't think in list. It's just unnecessarily complicated.
oh, it's not complicated, and you have to get used to it. Instead of having tons of variables, it's easier to store it in 1 variable because that's the way most data is stored. So let's stick to a list. So the x variable initially, what's it going to be? Well, which direction, like in x, we're going to move? Are we going to move left, or are we going to move right, or are we going to determine this randomly?
It wanted us to pick it randomly, didn't it?
Okay, so how can we determine randomly? Do we have random here? Yes, we do.
Random.rand int, and then parentheses between some value. I think I took like half of 10, like between 5 and 10. So we could do half of the velocity. I don't know if I did it right. I just took max of 10 and
But let's look at it. So if you talk about, we know the speed with which is going to move, like 10. It's like 10 pixels per cycle, for instance. So what does this mean in terms of its direction? How much is it going to change each cycle? How much the x is going to change and how much y is going to change? So for instance, if it's going left, what's happening to the x coordinate?
it's changing 10 pixels per cycle.
Yes, because we have ball speed at 10. So if at some point we decide to change this to 5, it's going to change by 5 per cycle. So we're not sticking to a very specific number, we're sticking to this constant. And we can actually use this here, but the only thing you could do this through rand int, but I think it's easier to do this through random choice, because choice is a function which allows you to select between any number of actual choices. In our case, we have only two choices. If it's moving to the left, it's going to be minus ball speed. If it's moving to the right, it's going to be ball speed. Right, so if we have 10, the direction to the left would be minus 10, direction to the right, the change in x would be 10. And this for us would be the direction for the x coordinate. If we talk about the y coordinate, I would say we would probably want the ball to go down. So when the game starts, the ball is going down. It's weird to immediately have it go up and knock out one of the bricks. So if we want it to go down, what should be the y direction here? What should be the number?
Just ball speed and ball speed, or just ball speed?
No, just ball speed.
Yeah, we're not doing random, so it's just ball speed. Okay.
Yeah, just ball speed, because we want to have it go down, and as it goes down, the y coordinate increases because we have the inverted y-axis, so it has to be the positive version. If we wanted it to go up, we could have done minus ball speed, but since we're doing it down, the y coordinate is simply ball speed. And
we're using a list here instead of a tuple because we can easily change the list.
Here, yes, I'm using the list, so this is in square brackets because the direction whenever it hits an obstacle, a brick, a wall, a paddle. So we should be able to change this.
Alex, I don't understand your list. And so what is the first element in your list?
It's the x speed.
Let me do it like this, so maybe it's a bit clearer. So this one is the x direction. So this is x. This is y.
Okay. And then why does the x direction have two?
Because it's random choice between two. The start of the game, it's either going to go left or it's going to go right.
So it's flipping a coin between left and
Oh,
right.
I see. Okay.
Exactly.
Well, I mean, couldn't the start also go up and down as well?
It could, but I just think it's weird that the game would start by the ball going out and actually knocking out one of the bricks before you even started the game doing anything. You already have one brick knocked out. So I would have it go down.
I would have actually thought that the start of the game, the ball would go down just because of gravity. Okay.
Yeah. That's how we set it up.
That's how we did it, yes.
Okay. Okay, because you're telling the ball to go left or right, but down.
Yeah,
And so it's gonna go kind of like diagonal.
exactly.
Or
Either
together.
either to the left or to the right,
Okay.
down.
Okay.
Okay. So this here we're done with. I think we have enough information about the ball. We have the ball itself. We have its velocity in a separate list with both the changes in x and y. So these two. Um, okay, so here it's telling us how it would move. And it says, let's get it to bounce around the world, ignoring the pedal and the bricks for now. So we need to create a loop, which will go round and round until the end of the game. So different ways how you could do this, but I would prefer to create a variable which would be like game end, and it's initially going to be false, and then I would have while not game end. While the game is not over, something is going to be happening here again and again and again until the game stops. So this is the main game loop in which we're going to play. So right now we're being asked to only move the ball, ignoring the bricks, ignoring the paddle, which doesn't exist yet. I'm not sure. Yeah, the paddle is going to be later. So just working with the walls. I think we're supposed to do this later, but maybe not. So inside this while loop, we will have a function which is simply called moveBall, because that's what it's going to do. We need the ball itself. We need the velocity of the ball, because that's how we're going to move it. And I think that's that, because we will need the canvas. We'll need the canvas. Because that's the way we're actually going to move the ball on the screen. So let me start writing this one. So move ball, we have the ball itself, we have velocity, we have the canvas. So how do we actually perform the movement of the ball? Is there anyone else besides Vicky and Martha who wants to jump in here? I'm more than happy to talk with either of you, but maybe someone else wants to chime in. How do we actually perform the movement of the ball? No one else?
Well, I mean, there's that command we learned from Baby Snake, right? You could move it to an absolute position or relative position. Is that what you're getting at?
Yes. So there are two ways of
Yes,
moving objects on the screen. One is absolute, one is relative.
relative.
In our case, do we want absolute positions or relative
I
positions?
think absolute position is easier for my mind to think of. So,
Okay.
so I use
Yeah,
absolute.
I'm wondering why. Because basically you have the current position and you have the information by how much you need to move. So that actually feels easier to do it by relative.
I liked just the move where you just had to feed it how much it changed, because you can use
Yeah,
velocity.
exactly. So that's the relative version.
I use the
I would
move too, but
Okay, but
I mean,
we took your colors and your list, so now let's try Martha's way and do the relative movement. So Martha, how do we? So it's going to be canvas move.
Yeah, and then the object is ball,
Yep.
and we need velocity. So change x is going to be what? Velocity with the bracket 0, comma, velocity bracket 1.
Yes. So because velocity is a list of two values, the first one is the x, the second one is the y. So that's how we change it. We change it by this one and we change it by that one. And it's always going to be either plus or minus ball speed. So it's going to move to that position. And this actually I look at it and I think this is a very weird function which only has one line. We can just take that line, place it here, and that's basically it. So maybe we don't even need the helper function because I don't think we need anything else here, right? Although no, hold on. I think this is a good place to actually check for bounds. So let's keep it here. I think, yeah, let's stay here. So do we need to check for bounds before we move the ball or after we move the ball?
Oh,
Well,
before?
I feel like it's after because your very first move is not going to be a bounce, right?
The first move is not going to be a bounce, but I'm thinking, at what point do you want the direction to change? Do you want it to change before it moves into, let's call it, illegal territory, or after it moves into legal territory?
I mean, you basically want it to hit like a wall and then it bounce, or hit the
So
paddle.
define hitting a wall.
Well, that's actually number four, goal milestone four. I mean, you want it to kind of collide with either a brick, a paddle, or one of the walls, um,
Right.
and then for it to reverse direction.
So yeah, what's your definition of the ball hitting a wall? Let's say
Okay,
the left wall.
okay. So for the XY direction, the way that I did it was, well,
Hold on, not the way you did it. Give me a definition. What do you mean when you say the ball hits the wall?
okay, it's very confusing now because like my variables are different than your variables, and so I have to
Whatever,
like,
you don't have to use variables. You can just say coordinate
okay,
X,
okay,
coordinate Y.
okay, fine. Okay. So basically, let um let me see. Okay. So basically that top left-hand coordinate of the ball, okay,
Yeah?
when it's less than zero,
Okay.
okay, in that case, that means it would have hit the left wall. And so it should revert. And then for the right wall,
Yeah. Let's now go into the right one because at the moment I wanted to check. I want to make this a bit shorter because I'm sure you can tell me go through the entire program, but we have only 12 minutes remaining. So the idea in your case is that actually when the ball moves past the border, you want to change direction and then push it back out. But for a moment, your ball is actually going to be outside of the wall in your
well, I
logic.
mean, you could just set it to like less than or equal to zero too.
But then if it's less or equal to zero, then you have to make that check before you change direction, not after. So because being at zero is already reason enough to bounce it, because that's when
Correct.
it's hitting
Correct.
the wall.
Yes.
Okay.
Yes.
Okay. So that's what Martha, do I understand correctly? That's what you were talking about as well.
Yes.
Okay. So let's try checking for the bounce of the wall. In which case are we going to change the x velocity? What would the conditions be?
So
Do you want the statement or do you want like,
Yeah, I mean, more specifically, if we have ball,
well, I mean, what I wrote is like if ball X is less than zero, or
how do you get, just help me out here. I don't remember how to get the x
well,
of the ball.
ball X is like that top left-hand corner, whatever you
Yeah,
call
I
that.
mean, what's the method to get the coordinate? Is it like get x or something? I don't remember.
it's, I know it's on the text on the left
Uh,
somewhere.
Yeah, I mean, if you don't remember, I'll find it myself, but I was hoping maybe you remember.
Nope,
I don't
don't.
think I needed it.
Okay, that's okay, because you see, I don't remember as
Yeah,
well.
it's
Okay, get
get,
left X.
yeah, get left X and then ball.
Ah, okay, it's for canvas. Okay, it's canvas, get left X,
I didn't use that, so
ball.
Yes.
Well, you probably don't use that because you have a separate variable to track
correct.
the
Correct.
coordinates.
Correct.
Okay, so yeah, I decided to bypass that because they're actually saved inside the ball itself.
Yep.
So if the X is what?
Less than 0, less than the ball radius.
If the, well, if we
For
go
the
about the,
0.
yeah, and let's go with equal as well. So if it's actually equal to 0, it's right at the wall, so it needs to bounce as well.
Yes. And so here, that's when we would take velocity 0 and reverse it.
Yeah, so you could say velocity 0 multiplied by -1, basically.
Yes.
But what's the second condition? We can add it here as well. Or what's the right wall?
I mean, you want that to be greater or equal to canvas width. Yeah.
Canvas width
Well,
and...
you want the bottom right coordinate to be greater than or equal to the canvas width.
Yeah, but since we
Minus
only
the
have
ball.
the left X, so we need to modify it. How do we get the...
Maybe get right X. I don't know because I don't know this command. I didn't use it.
Plus,
But if you have the left X, how do you get the right X?
Oh, it's like plus 2 times the radius.
oh, yeah.
Exactly. And if that one is more or equal than canvas width, correct? Is it canvas width?
Yes.
There we go. Okay, so if either of these two conditions is true, that means we've reached the left wall or the right wall. We need to bounce. Bouncing means changing the x or the x velocity to the opposite, and that's done by multiplying by -1. And actually, if we launch this right now, I think we would actually see the ball either deflect off this wall or of this wall. Let's see, I can't be certain because maybe we have bugs. Let's try. We simply don't have a ball. And I think the reason for that is it's so quick that it disappears from the screen as soon as it appears.
Because we don't have the time delay in.
Exactly, because we do not have a time delay. We do have time here imported, so we can do a delay in our main function. At the end of the while loop, let's say time sleep. Let's have a delay constant that we can change between runs if we need to, and it's going to be, I don't know, let's be 0.1. I think that's going to be very slow, but let's see. Okay, so pow, it kind of works. We could actually do, speed 1, but the delay is going to be smaller, and then it's going to be a smoother animation. It's not going to jump by 10, but it's actually going to jump by 1, but it's very slow. So there's probably something in the middle, maybe like this. Yeah, still very slow for my taste, but at least it bounces off the left wall. And let's try, it always goes left. There we go, right, randomly right. It bounces correctly off the right wall. So we need to do the same for the upper and the lower, and the logic is so similar that I probably can copy paste and just change a few things. So this one is going to be top y. If top y is less or equal to 0, or the top y plus the ball radius. We actually, well, let's do it for now that it will bounce off the entire screen. So do this like with height, and in this case our velocity 1 is going to change because that's the y velocity. And now, no, this is too slow. Let's speed this up. Okay, there we go. So now we have a ball which is constrained by the walls because each time it's near a wall, its direction changes. If it's the left or the right one, the x velocity changes. If it's the upper or the lower wall, the y velocity changes. So now we have the ball. We actually have the ball which deflects off all four walls. So the next thing we need to do is create a pedal. And you can probably guess that for creating a pedal, we're going to have a function which is called createPedal, which will also use the canvas, and it will return the created pedal, which we're going to store in a variable called wow. It's going to be called pedal. So let's write this function. Create pedal on the canvas. So how do we draw this one? Obviously, we'll need the pedal is a rectangle, so we're going to use canvas create rectangle once again with x, y. What are going to be the bottom right coordinates of the pedal?
The bottom right or the top left?
No, the top left are x, y, and we're going to write what x and y are here. My question right now, if we know x, y, what are the bottom right?
It's the bottom right. I put paddle width divided by 2.
But then you're going to have half of a paddle. So once again, if x and y are the top left coordinates of the paddle,
Right. It would actually be the paddle width.
Yeah, so it's going to be x plus paddle width.
Right.
And it's going to be y plus pedal height.
Wait, you made a typo.
Did I?
Yeah, you put x plus paddle height.
Yeah, because if x is the top left one, then x plus pedal height is the right one.
It should be pedal width. I think that's what you're saying.
Oh, okay,
Yeah.
That's what you're saying. Sorry, I didn't understand. Yeah, yeah, you are correct. You are correct. And we need, of course, to return this pedal.
It's not very often I find mistakes in like Alex Belyakov. So
when you do, you should feel, very good about it.
Yes.
Okay, so what's going to be the initial location of the pedal? And here's, I think you were talking about that one. The initial X, what's it going to be? Probably place it in the middle of the screen as well.
Yeah, so that one, I had canvas width divided by 2.
Yep.
Subtract by paddle width divided by 2.
Or you could do canvas width minus paddle width both divided by 2.
Yes, you could.
Which is the same thing mathematically. Also, I agree. Although I agree that the way you describe it makes more sense, but then you can sort of squish it. And for the y, I think it's given to us. Is it? I thought pedal y. We actually have a constant which is called pedal y. Thank you very much.
However, you want to subtract it a little bit so that there's an offset from the bottom wall.
I don't think it's actually touching the bottom wall, but
Really?
let's check it.
It was fine.
Yeah, so you see it has some space under it, so it's okay.
Okay. All right.
So, and we actually have the pedal, but now the thing that we need to do, we should actually be able to move this pedal with our mouse inside the main function. So first we create it here, but now inside the loop, we need to be able to move the pedal. So, and I'll stick to my idea of using helper functions. this one may be very short, but still, let's do this. So we'll send pedal and we'll send canvas to it. We don't need anything else. So let's define this one. Def move pedal. It's pedal and it's canvas. So the movement of the pedal entails a change of one of its coordinates. What coordinate are we changing and what coordinate stays put?
It's only the X.
We're only changing the X. So now the question is, we can get the X of the mouse. We actually have this written here. We can copy paste it. Mouse X equals canvas get mouse X. Done. So now the question is, what is the point? I mean, I'm trying to formulate the question. Like, how should the pedal be located in
Relative to the mouse X.
relative to the mouse? Exactly. Thank you.
Yeah.
Sometimes my English fails me.
The demo was centered on the paddle, so that where the mouse was, the paddle was in the center of it.
Like the center of the pedal across.
So
Yeah, it
we
should
couldn't
be
be
over.
lazy and just use mouse X as the left X. We had to adjust it to the center.
Okay, so how do we adjust the coordinate of the pedal? Because we're going to be moving the top left one. So we're going to be, are we going to use move or are we going to use move to here?
I use move to.
to.
Yes, because that's logical here. That's absolutely logical. You do not want to go into complex calculations how much you moved your mouse by, and then yeah. So move to is a lot more useful here. Okay, so it's obviously we're going to use to move the pedal. So the question: what's going to be the X and what's going to be the Y? Let's start with the Y. Y is easier. What's going to be the Y coordinate?
Pedal Y.
Pedal Y, that's not going to change anytime soon. So let's call this one X and define X. So what's the X?
It's going to be your mouse X.
Minus.
Going to be mouse
Minus
X, but
half of your paddle width.
minus half of the paddle width. That's true.
Which is I think 40 because they actually gave you the paddle width as 4.
Yeah, so we just use the constant when we don't need to use a specific number. So now if we run this, it gives us an error. Why do you give us an error?
The T move to, you capitalize the T.
I always do this. I don't know why I do this. I always feel that it's like that. So now we see that the X coordinate changes with mouse and it's always centered on the mouse, but we have a slight problem. What's the slight problem?
If you move the mouse off the canvas.
Yeah, this shouldn't be happening. This is like bad design. So the question is, I'm actually trying to play. This is like in my blood. So how do we stop it from moving outside if it, reaches here? We need to come up with a condition which prevents us, from happening.
Yeah. So limit what X can be to 0 or the canvas width minus the paddle width. So
Okay.
if X is less than or equal to 0.
But I mean, equal is unnecessary because if it's equal to 0, we're happy.
Then X is just 0.
Exactly. And the
If X is greater than canvas width minus the paddle width, then it is just canvas width minus the paddle width.
Exactly. Let's have another run and ching, 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 boop, boop, boop. I think now it works as as it has to work. It
Now,
does not.
I had a problem, and maybe this is probably where I was where I had the move paddle instruction in my breakout, but it was getting my mouse X when I was way off the canvas, and it was, oh, I guess, yeah, but that restricted it. Okay, never mind, never mind.
Okay. Okay. So now we've added the paddle, we have the bouncing ball, we have the bricks. So the next thing is check for collisions. And the only thing that bothers me right now is that we're already 5 minutes past end time. And obviously, the story with checking for collisions is the most important one because after this, I think things are pretty easy with the finishing touches. Well, except for the sticky pedal bug, but that's like extra. So my question is, do we want to spend time right now and work on milestone 4, or do we somehow move it to somewhere else?
We move it
Vicky,
somewhere else, this thing is never gonna end. And so how
of
about just
course,
like whoever
of course,
whoever
I
wants
am
to stay.
prolonging this. You said that I like what did you call me? You said that I like suffering or something similar. So I am prolonging the suffering.
No, I mean, I don't think I ever said that. I think you're just like creating, words. Um, but anyways, I could stay until 10. And so I will keep on recording you, and then whoever has to go, do not feel offended. You
You
know,
yeah, you can always watch this in
yes.
recording if you have to go.
Um, Alex is not going to be offended. Definitely feel
No,
free to go if you have other things to do.
cool.
You're going to be able to finish this in the next hour, right, Alex?
I would actually want to finish it in the next half hour because I would have to leave after that. So yeah, let's try. Just give me a second. I want to turn on the air conditioner in here. Suddenly it's getting like hot and sweaty. We're getting to the interesting part. All right, so now let's go back to our main function. Inside our main function, inside the loop, we move the ball, we move the paddle, we do the delay, but so far nothing else. So now we need to check for collisions, and the things that we're interested in, we're already checking for collisions with the walls because it's here in move ball. But we need to check collisions with bricks, and we need to check collisions with the paddle. And in the milestone, I don't remember whether they're telling us which one is more interesting, which one we should do first. I don't know. Let's first try, doing it with the paddle. So let's do a function which is actually going to be called check for collisions with everything. And we're going to have the ball in here, we're going to have the paddle in here, we're going to have the bricks in here, and do we need the canvas? I think we do. Do we? I'm not sure actually. Let's keep canvas off for now and then we'll check. So the next function is check for collisions, and it has the ball, the paddle, and the bricks. And let's first start with the paddle. So we actually have here a function which is called canvas find overlapping, and then we have some coordinates. And the question is, we want to check, this function gives us a list of objects which are actually at least partially inside this rectangle. So something that is overlapping with this rectangle. So the question is, what is the rectangle that we're actually looking at?
The one around the ball.
Exactly. We are interested in the ball. What's the ball intersecting with? And we have the coordinates of the ball, but let's do the x, y one more time. If I remember correctly, it was canvas get left x ball and canvas get top y ball. And now here we have x, y, x plus ball radius multiplied by 2, y plus ball radius multiplied by 2. Am I correct here? Because I could be making some logical mistake. Does this look good?
I think so.
Okay, well, we'll find out sooner or later. So now, the first thing we'll check is whether it hits the paddle. And in order to do this, we can write a very simple condition. We're going to say if paddle in colliding list. Because the colliding list is the list of all the objects that overlap with the ball, and we can actually check whether the paddle is in this list. And if it is, what do we want to do? What's the action that we want to perform?
We're going to change the y direction.
Yes, and in order to change the y direction, we actually need we can either pass it or return it, but since lists are mutable, I can actually change the list inside the function, and it will change outside the function.
So we don't have to pass the velocity to the function.
Yes, I do need to do this. This is absolutely
okay.
Correct. So I will pass velocity as another parameter here. I will receive it here, and now I can actually change it. So which velocity are we changing, the x or the y?
Y. So it's
which is index 0 or 1?
1.
1. And we're also doing this. And basically that's that. Now we should be having bouncing, sorry, what's the hold up? Canvas not defined. Oh, okay, obviously. Now that's the reason why I need the canvas. If I want to get something from a canvas, I actually need to pass it in as a canvas. Quite logical. All right, so now suddenly our paddle is working sort of as intended. Let me try to get the, okay, there we go. There is the bug with the sticky paddle. So this is something that needs to be taken care of, but we're not going to talk about it right now. We're hopefully going to talk about it at some other time. We're done checking collisions with the paddle. So the next one we want to work with is the bricks. And the way, any idea of how we could do this, how we could check? I mean, there are 100 bricks here, and we need to check whether the ball collides with any of those bricks. How do we do that?
You could keep a counter.
I'm sorry, I don't understand the word of what you're saying.
Sorry. You can keep a counter, which means like every time you collide a brick, the counter increases by 1. And then you have like a total of like 100 bricks. And so once your counter hits 100, that's a potential game ending condition.
Yeah, but I'm not asking about the game ending condition. Although that's a good idea, I'm asking how do I check for collision with each of the 100 bricks which are on the screen.
So we want to see if anything in the colliding list is in the bricks list.
Okay, so we could write if anything in the colliding list is in the bricks
I ended
list.
up looping through everything in the colliding list and just
Right.
if it was
Right. I think this is a good idea. So we're going to go for, I don't know, let's call it like item in colliding list. And here we're going to say if item in bricks, is that what you're saying, Martha?
Yeah, yeah.
If this item is in bricks, then what do we do?
I deleted the brick, but then I had trouble limiting it to just one brick. Like I just want the first one to get deleted.
Sure. Okay. Well, yeah, let's discuss this one. So first, let's delete it. Can you help me out with the syntax? How do I delete a brick from?
Canvas dot deletes item.
So is this one? And I think we also need to delete it. Do we need to delete it from the list as well?
Oh, what? So the list won't get cleared
I'm not
after.
sure because I think that you would still have it in the list, although it would be deleted from the canvas. So these are two different data structures which keep information about. I think I'm just thinking if that's actually true right now. So we have the object inside. I think we delete the object, but it does not get deleted from the list because the list is still saying like there is 100 of them. So we need to do both. So how do you remove an item from a list by value?
Oh, I don't remember.
You could
Actually,
delete based on the indices, like pop.
yeah, but you don't need the indices because you would need to find the index and then delete by it. But you could do bricks,
Remove.
remove brick. And this would remove whatever has this value from the list.
Wouldn't that be item instead of brick?
Yes, sorry. Yeah, you're absolutely correct. Of course, it has to be item. And
Couldn't we just clear the colliding list with every iteration and not have to worry about removing it from the colliding list?
but I'm not removing it from the colliding list. I don't care about the contents.
Oh, okay. This will help us limit the number of bricks that we remove too. Okay.
Okay, the way to answer your question, how we could limit to just one, if you find an item in bricks, you delete this item and you remove it from the list.
And
The
then
next thing you could do is just simply type return. And what return does, it stops the entire function from continuing on. It will return control into the main function. So the first one you find, in the list will be removed, and that's that. So you will basically break out of this loop.
And every time we call the check for collisions, does that give us a fresh colliding list or?
Yes. So each iteration, we will get a fresh colliding list because here it throws out the old one and replaces it with the new one.
So do we really need to remove the item from the colliding? Oh, we're removing it from the main list. Okay.
Yeah, we're removing it from the bricks list, it's just a list of pointers to memory that store the objects, which are the bricks.
Yeah, got it.
And here I think it's actually removing it from the canvas so it stops being visible.
And that's what I focused on, but I didn't remove it from the original list. Okay.
Yeah. So let's see what goes on here, because I'm trying to understand whether that's all we need to do or we're still missing something. So let's try doing a boink. Okay, so it's working. There is obviously something we forgot to do. So now we're actually playing a game which gives us a super power up where the ball blasts through all the bricks without ricochet.
So we need to change the velocity also.
Yes, that's the thing we forgot. And the question here could become like, which velocity do we have to change? Because if you hit the brick from the side, doesn't it have to change the x velocity? But this is like where it gets really weird, because then you'd have to actually see from which direction the ball hits the brick, and you would have to go check the x coordinate and the y coordinate of the ball, compare it with the x coordinate and y coordinate of the item, and see, you know, from, in your opinion, from which side it approached the brick. And the trouble with it is that our ball jumps by 5 pixels each time it moves. So it could actually end up in the middle of the brick, and you would have no idea how it ended up there. So to make this simpler, I would actually, stick to making it bounce vertically, not horizontally. So before returning, I would also add this. After it, we find a brick, we remove the brick, we change the velocity, and we should be, good. There we go. That's the first one we hit. That's the second one we hit, and so on and so forth. So this should work fine. I'm not going to wait for it to destroy all the bricks. But the interesting thing is that once you have a hole and the ball reaches the upper part of our canvas, it should start bouncing back and forth and destroying the bricks on top. So this would work as well, because it will change velocity from going down back to going up, and it will bounce back and forth between the top wall and the actual bricks. Okay, so I believe we are done with checking for collisions. So now the question is, I think Vicky talked about this, how do we actually understand that the game is over? And Vicky proposed that we actually have a counter, like, you have a counter 0, and each time you destroy a brick, you add 1 to this counter. And if the counter is 100, that means you destroyed all the bricks, you are done. Do I understand correctly, Vicky, your idea? Yeah. But there is a slightly easier way. I like your thinking, but there is an easier way, because we actually have this counter already. Because we have the length of the list of bricks.
You basically used a list, whereas I didn't use a list. And so if you use a list and store all the bricks in a list, you could just check when the length of your list is equal to 0, you're done.
Exactly. That's what I'm going to do. I'm going to write somewhere here, if length bricks is equal to 0, then game end equals true. And now, so if I destroy all of them and the list is empty, this will trigger the end game. This is the first condition for the game ending, but there is obviously a second condition which has to do with lives, because you only have 3 lives. If the ball, instead of bouncing off the bottom wall, it has to take one of your lives. So for this, we need to actually have a variable which is going to be called lives. And here we're going to have or lives equals 0. So these are the 2 conditions for the game ending. Either no more bricks or no more lives. There are no other condition. In this case, if game end true and this cycle ends. And the way we're going to check for this is when we move the ball. Right now we have, here we have code for bouncing off the bottom part as well, but we need to remove this because this is actually not correct. We can bounce only off the top wall vertically. However, I don't know why I actually deleted this. I will take this as a separate condition. I will say that, how would I actually do this? You could say that if you reach the bottom, instead of changing your velocity, you would actually return your number of lives. So we need to I'm thinking which way would be better to do this, to pass lives here as a parameter or return return some value like true or false, which signifies whether we lost a life or not. Let me return the number of lives. I don't like it. Let me return true here, and I will return false in all other conditions. So basically, if I hit the bottom of the screen, I return true. This true signifies sort of you lost a life. In all other cases, you did not lose a life. I will need to then write a condition here where I have move ball. I will say like lost life. I will save this true or false into lost life, and I will say if lost life, which means if it's true, then lives minus equals 1. But there is also one more thing that I need to do when I lose a life. Besides doing this, I need to reset the entire, well, not the entire, I don't need to reset the pedal, I don't need to reset the bricks, the only thing I need to reset is the actual ball. And since I have the ball here, I can change its location by doing move to the center of the screen. Not move, sorry, canvas move to ball, and then I think we already did this once. This one. We'll get the X and the Y. We'll move the ball once again to X and the Y. So here we're resetting the ball to its original location, and we need to reset the velocity. So we can once again do this, but then we need to reset it. Not here. Let's do it in main. In main here. And since this is going to look ugly, we have this code duplicated in 2 places. I will actually write a function which is going to be called getVelocity, or I could go getRandomVelocity, and I'm going to use it here as well. And this function, I'll write it here so I don't have to go down anywhere. Get random velocity. It gives me this list, or I can actually just type return this list. Yeah, I think this should work. So now I have simply a function which gives me a random velocity each time I need it. So I, instead of using this twice, I use it only once, and then I call this function either here or here. Let's see what that gives us. If len bricks, what don't you like? Invalid syntax. If len bricks equals 0 or okay. Here's the mistake. Okay, so this works. Now let me try dying. So this is my first, and then no. Okay, I'm using move to with capitalized letter one more time. Like, this is a bad habit that I have that I need to. Okay, so now this is 1, this is 2, this is 3, and that's game over. So basically, of course, the ball returns to the center of the screen, but the game is done. You see, I can't control it anymore. It's over. So we took care of the case where the ball hits the bottom wall. We are checking for both terminating conditions, though I'm not gonna really check for the 100 bricks because that's going to take a long time. Although we can actually, you know what we could do? We could actually do a check. Let's return to our power ball. Let's not change our velocity when the ball hits the bricks. And I think then we'll be able to clear the screen a lot faster. If we go through this in its entirety, maybe we'd be able to Okay. I'm not actually sure whether this is going to be clearable because the way it looks right now, it just goes through all the holes over and over again, and this could get very frustrating given the initial positions. This could go on forever. I don't know.
You could lose your life and get a different random starting X.
Okay, no, it's starting to pick up. I think it's very algorithmic, so it will probably. I think this one will do it. There we go. And we also the game ends, so the program is done. So we're done with both terminating conditions. We actually have the game play 3 turns, so we're done with this. And the only thing that I don't think we're going to be able to actually write the code right now, but I know at least Carlos, I saw your, I don't know whether Carlos is still here with us or not. Yes, you are, I can see you. So I saw your question, how to handle the sticky pedal. Could you maybe in a couple of words describe how you did it? If you're actually physically still here with us and not just a ghost. Has anyone else done this issue, like resolved this issue with the sticky pedal? And
Yeah,
does
I
anyone?
mean, I tried to, but the problem is I don't know if my solution worked because I could never replicate the bug, and I'm not sure I understood what the bug is really trying to do. And so
So
I'm
you
not
can see
sure.
here if the ball strikes the side of the pedal, this is how you get the bug. It has to strike the side and not the top of the pedal. So
Strike the
like,
side of the paddle. Oh,
yeah, like the
well,
left or the right side. I'm trying to do it right now, but it's a bit difficult in some situations.
well,
I
what
think I
happens?
saw, yeah, let me, ah, no, this is a bit hard. Let me try one
Right.
more
I
time.
mean, I could never.
Yeah, I see an answer from, I just
So, so,
tested the
so
coordinates
basically
of
what
the ball
it's
beyond paddle Y.
it
Okay,
keeps
so
causing the paddle and the ball to overlap, and it just keeps changing the X velocity. That's why it jiggles.
yeah, so the problem is that when it goes in, it sort of goes back and forth because it's overlapping the pedal for like in each iteration, and it can't basically get out of the pedal because it goes back and forth, back and forth, back and forth. And one of the ways that this could be resolved is that once you have the ball intersect with the pedal, you would need to create a separate Boolean variable which states whether the ball actually left the pedal or not. So it would be false until there is actually no more intersection. And while it's false, you do not change the velocity back. And you would need to check this variable each time before you change the velocity, and then only once it clears the pedal, you allow it to change the velocity on the next time that it hits the pedal. So that's one of the ways that you could
Do you
do
think
it.
it's possible just to extend and then have kind of like a break of several what's the word I'm looking for? Sorry, frames before the ball leaves the paddle again?
But then it's the question, like right now we have a very specific ball size and a very specific pedal size. But these are things that could be changed. So for instance, if I go, if I go here and I say I want my pedal to be not 15 tall, but I want it to be like 50 tall, and I don't want my radius of the ball to be 10, but I want it to be 3, and then suddenly you have this exacerbated because you see it's very easy to get the ball to get caught inside the pedal. Like,
No, but um what I was
so
saying
it,
is
so it needs
like
to be a universal solution. That's what I'm saying.
right. Because you could just have the computer, ignore the paddle collision for a very short amount of time after each bounce, and then have it start bouncing again.
Yeah, you could probably do this some way. The problem is that we check time only at the end of the main loop, so after the end of each iteration. So then you would have to check this time somewhere inside one of
Correct.
those functions, which I think makes it very icky, for lack of a better word.
Okay.
That's not a good place to check your to do the delays. So that's my idea. That's what I would have tried to do, but it's not the only option. You could do it. I'm sure there are other ways of doing this. This is a very popular problem to have with Breakout. I mean, every person writing this game runs into this problem unless your speed is 1. If your speed is 1, then you never go far enough into the pedal to actually get stuck in it. But then the game is very slow. For instance, in the IDE, even if you place a very small delay, the game is excruciatingly slow. It's just impossible to play it. But then you never get stuck. It's so like, oh, you even get stuck here. Oh, I managed to do this. So no, that's not a solution. Yeah, ball speed does not help. All right, so I think we've done more than enough for today. And I say we end here. So thank you to everyone who actually stuck until the end. You are my heroes. And next time, so next week it's going to be images. It's going to be Vicky talking and showing you stuff.